Hello friends. The remaining topic we have to complete in this lecture. What is the principal of operation of the impedance relay? So there are the two conditions for the impedance relay: normal operating condition and the abnormal working condition. That means fault condition and the normal condition. So in the normal condition, the value of the line voltage is VL is more than the current. That means the maximum than the current. But when the fault occur, this is the normal operating condition. Then fault condition, under fault condition. In this under fault condition, our fault if the fault occur on the line, the magnitude of the current is rises. The current, the magnitude of the current is rises, and the voltage become less, and the voltage become less, and the voltage becomes less. Current is rises and voltage becomes less. So, but when the line current is inversely proportional to the impedance of the transmission line. So the line current is, so this is the line current. Just wait, annotate, clear all drawings and close. So the line current is inversely proportional to the, so this line current is inversely proportional to the impedance of the transmission line. So the impedance is decreases. So the impedance is the decreases because of the impedance relay starts operating. So this figure explain the relay in much easier way, because the potential transformer supplies. So this is the potential transformer, and this potential transformer supplies the voltage to the transmission line, and the current flows because of the current transformer. So the current transformer is connected in a series with the circuit. So now consider the relay is placed on the transmission line, and is placed on the transmission line for the protection of the line A and B. So the impedance relay, that means the Z, it is the impedance of the normal operating condition. This Z is the normal operating condition, and if the impedances of the line fall below the impedances, then the Z is working, that means then the relay starts working. Let the fault F1, so this fault F1 occur in the line A and B. So this fault is decreases. So this fault decreases the impedance. So this fault decreases the impedance of the line, uh, impedance of the line, and the relay setting impedances, and the below the relay setting impedances. So the relay starts operating, and it's send the tripping command to the circuit breaker. If the fault reach beyond the protective zone, the contacts of the relay remain unclosed. So I will repeat again. It is nothing but when the fault occur on the system. When the fault occur on the system, that means this F1, it will be the fault. So when the fault occur in section A and B, so, and this is the Z, this is the normal impedance, and this is the fault impedance. Okay, this is the normal impedance. That means this is normal condition. So what is the normal operating condition, and what is the fault operating condition? So you have to note these 2 points, because the normal operating conditions and the abnormal operating condition, it is very very important for the understanding of the impedance distance relay. Now, you have to operating characteristic for the impedance relay. So what is the operating characteristic for the uh, operating characteristic of an impedance relay? So the voltage and current. So this is the voltage on the x-axis, and this current is on the y-axis. So operating elements are the two important component of the impedance relay. So the current operating element. So the current operating element generates the deflecting torque. What? The current operating elements, that is this current operating element generate the deflecting torque. Deflecting torque. Okay. Deflecting torque. So this deflecting torque, while the voltage storage element generate the restoring fault, rest, restoring or restriking torque. Okay, this is the restriking torque. Restriking torque. In the x-axis, there is the deflecting torque, and on the y-axis, sorry, the x-axis, that is the voltage, there is the restriking torque, and the y-axis, there is the current, it is the deflecting torque. So the torque equation of this relay, so the torque equation of this relay, it is nothing but the torque is equals to K1 I square minus K2 V square minus K3. So what is this K3? This is the constant. Okay, this is the constant. This is the constant. So the K3 is the value. The K3 is the value of the spring effect of the relay. And V and I is the current value for the voltage and the current. So when the relay is in the normal operating condition, then the net torque, then the net torque, just wait, I will erase this all the things, and just wait. Yes. So K3 is spring effect of the relay. Okay. This is the spring effect, and voltage and current is the uh, values of the voltage and current. So this is the V voltage and current is the I. Then what is the equation for the torque equation? The torque equation is nothing but there is, yes, the torque is equals to K1 I square minus K2 V square minus K3. Okay. So K3 is the spring effect, and voltage and current is the value of the voltage and current. Now, when the relay is the normal operating condition, when the relay is in the normal operating condition, that means the net torque of the relay becomes a 0. That means net torque equals to 0. So the torque equation is nothing but K2 V square. K2 V square is equals to K1 I square minus K3. Okay. Then you will get voltage upon current is equals to impedance. It is nothing but your impedance. So resistance V upon I is equals to impedance. It is equals to the V upon I. Then you will get K1 upon K2, K1 upon K2 minus K3 upon minus K3 upon K2 I square. So if the spring control effect becomes neglected, this equation, it is nothing but for the normal equation. In that case, the net torque of the relay becomes a 0. Now, when the spring control becomes neglected, and the equation you will get the impedance is equals to under root of K1 upon K2 constant. K1 upon K2 constant. So the operating characteristic of concerning the voltage and current as shown in the above figure. So this dash line is in the image is represent the operating condition at that the constant line is the impedance. So the operating characteristic, of the impedance relay as shown in the figure below. So in this figure, the positive region, there are the two regions are there, positive regions, negative regions. So in the negative regions or the positive regions, so first positive region, The torque is of the impedance as shown in the above operating characteristic of the line. What the positive torque region, this positive torque region of the impedance relay is above operating characteristic. And for the positive region, impedance of the line is more than the impedance of the faulty section. So similarly for the negative region, impedance faulty section is more than the line impedance. So this is nothing but therefore the positive torque regulation, and this is for the negative torque region. So the impedance of the line represented by the radius of the circle. That means it is represented by the radius of the circle. So the phase angle between the x and r, x is represented the position of the vector, position of the vector. So if the impedance of the line is less, just wait, I will clear this all the diagrams. That means this is the Rx diagram. Okay. So for this Rx, the phase angle between, that means phase angle between, um, the phase angle between x and r, x and r, it represent the position of the vector. It position of the vector. So position of the vector. So if the impedance of the line is less than the radius of the circle, it will show the positive torque, and if the impedance is greater than the negative region, it show the negative torque. So this is nothing but for the positive torque, and this is for the negative torque. Now, this type of relay is also called as the high-speed relay. Now, the conclusion of this relay, we will discuss. Now, we will discuss the impedance of the these three fault is different. That means there are the three conditions. Three conditions are there. So, first condition is nothing but I will draw here the one table, and this is very important for to understand the RX diagram. So we have already discussed this Rx diagram, but for the these three natures for the impedance relay, first is the fault, then nature, there is the fault, then nature, then fault current magnitude, this is IF, then voltage to the relay coil, voltage, voltage to relay coil, and then and then the relay condition. Then last one is the relay condition. So these are the parameters for, you have to write down the different fault. So first is the fault F1, then it is the nature, it is internal, then the fault current is IF1, the current magnitude, fault current magnitude, it is the IF1, then voltage relay coil, it is the V1, and last one, it will trip, that means to operate. Then second is the F2, it is the boundary point, it is the boundary point, and for internal fault, then fault current magnitude IF2, then voltage to relay coil, it is V2, and last one, relay condition decide on the verge of the operation, on the verge of operation. Last one, F3. Last one, F3. So for F3, it is external fault, IF3, then voltage to relay coil V3, and it will be should not operate. What is the relay condition? Should not operate. So above in this table, there are the three conditions along with the respective quantities. First is the F1 for the internal, F2 for the boundary point, F3 for the external point. So the fault current is depending upon the impedance up to the fault point. So the voltage of the relay coil is V1, V2, V3, and the relay current is the I1, IF1, IF2, IF3. But the voltage to the relay coil, it is depending upon the fault current. That means it is nothing but IFZ drop. IFZ drop. So we can decide the impedance value. Impedance value, that means you have to search that the product of fault current into the Z set, because you have to decide the impedance value, as it can be set as base for the relay operation. So that is this product exceed the particular limit, so the relay should trip. Now, according to three condition, that means you have to set the value for the impedance. That means the first condition, I will just wait. This annotated will be erase is there. So I will write here. Okay. Yes. So first, I will write only the first case. Then you have to again write for. Then you have to try for the second and third condition. So first is the F1. Okay. You have to set the impedance value so that the product is IF and Z set. So F1, then IF1 Z set, and then it is greater than V1 and relay will trip. Similarly, for the F2, IF2 Z set is equals to V2. That means on the verge operation. And F3, this is F3, IF3, F3, IF3, Z set is less than V3. That means relay will not operate. So the VI characteristic. So the VI characteristic, I will clear all the diagram. So now the VI characteristic, this is the simple impedance relay as shown in the figure. So if the operation of the point F1, so it is nothing but the conditions for the positive and the negative. Similarly for you have to draw the diagram for the these three condition, internal, boundary, and the external. So in this RX diagram, you have to draw the same condition. There are the three conditions F1, F2, and F3. Then you have to draw like this. This is nothing but first is the internal, this is the F1, then boundary point, that is F2, and last one is the mal operation. External is the last one is the external. So according to the, if the operating point F1 will relay to operate, and if the point F2, then the relay will be on the verge operation. Then the operating for the F3. So this is nothing but F1, F2, and F3. The relay will not operate, but above characteristic, it is plotted the RX plane, and for the more informative base. So in the characteristic of the x-axis, the resistance axis and the y-axis. The resistance and the y-axis, that means this is the fault characteristic is there. This is the minus R. This is positive R. So resistance axis and the y-axis reactance or x-axis. The resistance axis represent the real part. Resistance is represent the real part, and x-axis, that means the reactance part. It is represent the imaginary part. So the fault taking place on the transmission line is a straight line, and the trip region within the circle and restraint region is the outside ridge. Then this region is very small area for the better reliability of operation. So if the trip region is large, it may happen that the protection scheme malfunctions and discrimination is affected. So the consider these three faults f1, f2, f3. Now these are the shown the fault characteristic of the rx diagram. So f1 lies in the trip region, f2 lies on the boundary region, and f3 is the mall operation. So this is all about the impedance relay. So similarly, you have to uh, study. You will do the study for the same for the Moore relay and for the reactance relay also. So first we have to understand what is the basic principle for the Moore relay and the reactance relay, then characteristic, and then Rx diagram. So when you know the what is the working principle for normal condition and the abnormal condition, then definitely you have to draw the Rx diagram also. So thank you.